This is question number 26, and again, it's not a multiple choice question. None of the questions hereafter will be multiple choice. This is on the January 2017 Common Core Algebra 1 Regents. What we have is a typical marathon is 26.2 miles. Alan averages 12 kilometers per hour. Now, these are different units, so we need to bear that in mind. When running in marathons, determine how long it would take Alan to complete the marathon. So we're looking for time. And what we need to remember here is distance is velocity or speed times time. That's derived from the definition of speed or velocity, which is distance over time. What I've done here is I've gone ahead and copied the conversion chart from the other scale here from the back of the test. There's a little bit of a reference sheet, and I've just copied the parts that are relevant here. Now I've gone ahead and highlighted the portion of this that's going to be helpful in this question because we need to convert miles to kilometers. There are two ways to do this, and the easier way would be to convert the number of miles to kilometers. So 26.2 miles is the distance that he needs to travel, but let's convert that to kilometers. Well, we see here that 1 mile is 1.609 kilometers. So all we have to do is multiply this by 1.609 kilometers. Now, some of you will also know dimensional analysis, where we would put this over 1 mile. That's not going to affect your answer. The unit miles divides out, and we have 26.2 times 1.609. And we could substitute that right in with this conversion and put this right into our calculator here. And we get 42.1558 kilometers. That is still the distance of the marathon, but now we've gone ahead and converted it to kilometers. And we know his speed now in the same units, which is 12 kilometers per hour. So we're trying to calculate the time. So I would use either of these equations. Now I've got d equals vt here. It's a little bit easier to work with. So taking d equals vt, distance is the speed times the time, I would put in, oh, this isn't t, my apologies. That's definitely v, the speed. So I would put in the d here, which is 42.1558. And we know the speed, which is 12. And we know the time is what we're looking for. So divide both sides by 12. Again, we can just do that right in the calculator. So if we divide that by 12, we get a t of 3.513 hours. And it does say to the nearest tenth of an hour. So we could just truncate that to 3.5 hours. No rounding up required because the next digit is a 1. So that's that. And the key to this question is just doing the conversion here. This is the most important part of this entire question. And again, my apologies. I had originally labeled this as t. That's obviously the speed, not the time. We are told that's the speed with which he runs.